So this video goes along with solving more advanced problems of similar triangles. So I want to start with highlighting what two triangles I'm talking about. Okay, so in yellow, here's one of my triangles. It's triangle ABC. So I can start to write a similarity statement here saying that triangle ABC is similar to this other triangle that I'm going to highlight in orange. Now the orange triangle is the larger triangle, the biggest one that we can kind of see here. So I'll highlight that. And the orange triangle, if I want to name it in a similar way, would be triangle ADE. Now the reason why writing these similarity statements is going to help me is that helps me match up any other corresponding parts. So when I write the side ratios, having AB means that it would correspond with AD. And again, this is going to help me when I go to write the ratios. Now, I'm looking for this little segment in between B and D. Now, I can't find it right off the bat because it's not its own side of a triangle, right? It's a piece to a side. It's part of that long bottom side, but it's not its own side like this 14, or if I knew A to E, how that would be. It's not its own side, it's part of a side. So what I need to do is I can say, okay, well 5 is this vertical height of the triangle, C to B, and it corresponds with E to D, E to D. Okay, well I can use this ratio of 5 to 14 to help me find this piece that I'm missing. So I need to take another short side of the small triangle, which is 6, and write it over the corresponding side of the big triangle. Now it's not its own side. This bottom length is the piece that's 6 and the piece that's x. So I need to combine both of those in the bottom here. Now to solve a ratio, we have to cross multiply. So 5 times 6 plus x equals 6 times 14. Let me go grab a calculator really quick, but you can also work this out while I'm going to grab a calculator. Now, the part with the 5 I have to distribute, which means I have to multiply the 5 to the 6, which is 30, and to the x, which just leaves me with 5x. 6 times 14 is 84. And now take the geometry out of this, guys. It's a two-step equation that I can solve. I need to combine like terms by moving the 30 away from the x. 5x equals 54. Divide both sides by 5. And x equals 10.8. And that's it. The second problem, similar, but our ratio is slightly different. So again, like I did in the first problem, I'm going to highlight my small triangle in yellow and the largest triangle in orange. This is going to help me see which sides, which parts are corresponding, and really when I have to combine things and when I don't. Now, if I want to set up a ratio, this vertical side of 2 corresponds with this vertical side, x. So I can write them in the same ratio. I also know that this bottom side of 4 corresponds with this bottom side that is 4 and 3. So this bottom side of the yellow triangle is only 4, but the bottom side of the orange triangle, the entire thing, is really 7. I can solve this ratio in the same way. 4 times x equals 7 times 2. And if I just want x, I divide both sides by 4.
Attention, please.
So in this case, x equals 3.5. Now, you might be wondering, what makes these two problems different? So I just want to talk about how they're slightly different. Get my ring stand out of the way. In this first problem, the variable we were solving for was only a piece to the bottom side of the big triangle. In the second problem, the x was its own side of the larger triangle. So here, it's a piece. Here, it's the whole thing. So notice that slightly affects how we set up our ratio. We had to add things together to get a full side length. Here,